Hi children, in the last class we have studied what is meant by atomic number of an element. What is an atomic number? Atomic number is the number of protons present in the nucleus of an element, nucleus of an atom of an element. How many protons are present in the nucleus of an atom? That is known as atomic number. For example, atomic number of sodium is 11. What does it mean? It means that in the nucleus of every atom of sodium, in the nucleus there will be 11 protons. Okay, and we have already seen that atom as a whole is neutral. It has no charge at all. So we have concluded in the last class that in a neutral atom, number of proton is equal to number of electron. So atomic number is equal to, atomic number is represented by the letter Z, that is equal to number of protons, and we know as it's a neutral atom, that is again equal to number of electron. So atomic number is equal to number of proton in the nucleus, that is again equal to number of electron in the atom. Electrons are not in the nucleus, they are revolving around the nucleus, outside the nucleus, in the empty space. Okay, but in an atom there are protons and electrons. Atom as a whole is neutral. So if the number of proton is 11, in that atom number of electron is also equal to 11. We have to by heart the atomic number of elements up to 20. See, I have written all the elements, atomic number up to 20. The hydrogen 1, helium 2, like that. We need to by heart the atomic numbers of all elements up to atomic number 20. Okay, now today we learn another term, that is mass number. You know that in the nucleus of an atom there are protons and neutrons. The total number of protons and neutrons in the nucleus of the atom is known as mass number. That is denoted by the letter A. That is equal to number of protons plus number of neutrons in the nucleus. In the case of sodium, its atomic number is 11. So number of proton will be 11. And its number of neutron equal to 12. So its mass number equal to 23. Mass number is represented by the letter A. So mass number of sodium is equal to 23 because its nucleus contains 11 proton and 12 neutron. So mass number is the sum of the number of protons and neutrons present in the nucleus of an atom of an element. So mass number of sodium is 23. Now if we know the mass number and atomic number of an element, very easily we can calculate the number of neutrons in the atom. For example, chlorine, its atomic number is equal to 17. Its mass number is equal to 35. So what is the number of protons in the atom? Number of protons is equal to atomic number. So that is equal to 17. What is the number of electron? Number of electron is equal to number of protons. So that is also equal to 17. What is the number of neutron? Number of neutron is equal to, how will you find out? Because mass number is the total number of protons and neutrons, and atomic number is the number of only protons. So suppose you subtract atomic number from mass number, you will get the number of neutrons. So that will be equal to 18. Number of neutron will be equal to 18 because mass number is the sum of proton and neutron. This is only the number of proton. Simply subtract atomic number from mass number, we will get the number of neutron. Let us see how we can represent symbolically an element with its atomic number and mass number. Okay, see here, chlorine, its atomic number is written here on the left side as subscript, and mass number is written as superscript on the top right side, 35. But mass number can be written like this also, 17. Mass number also can be written on the left side also, either on the right side or on the left side, but as a superscript. Atomic number is written always as a on the left side as a subscript. So the common representation is, if X is an element, its atomic number is written here. Atomic number is represented by the letter Z and mass number is written by the letter A. So this is the common representation for every element. Write the mass number here and atomic number here, or mass number here. There are two options. Mass number can be on the right side or on the left side. So let me ask you, how will you represent the elements? Looking in the textbook, you can find out the atomic number and mass number of nitrogen. For nitrogen, atomic number ma'am has written here. So its atomic number is 7. So that is written as a subscript 7. Its mass number is 14. So we can write it here or else here. Both are correct. Okay, this is how we represent an element symbolically with its atomic number and mass number. Now in your textbook, in page 43, there is a table. I told you there is a table in which the atomic numbers and mass numbers of the first 20 elements are given. You need to by heart these atomic numbers and mass numbers of the elements up to 20. So for next day, by heart the atomic numbers first. After by hearting atomic numbers, I will tell you a trick to by heart the mass numbers. Okay. Now after that, in page 44, the next topic is isotopes. That is not there in the syllabus, so we don't have to study it. Then in page 45, we will start. That is electronic configuration of atom. What is meant by electronic configuration? In an atom, we know that there are protons, electrons and neutrons, and we have already learned inside the nucleus protons and neutrons present, and electrons are moving around the nucleus in different orbits. This much we have already learned in the previous classes. Now how these electrons are arranged in different orbits or different shells, that is what we are going to study. So the arrangement of electron in different shells of an atom is known as electronic configuration. We know that atomic number is equal to number of proton, that is again equal to number of electron. So how in the case of sodium, we know that atomic number is 11. So there are 11 electron and 11 proton. Protons are inside the nucleus. Where are these electrons? Electrons are moving in different shells. Which electron in which orbit? That is what you have to decide now. So electrons are arranged in various shells according to some rules. Okay, so we are going to study that rule. First rule is known as 2n square rule. So 2n square rule means, before that let me tell, you know there are different shells. The shell closest to the nucleus is known as first shell. That is known as first shell. And the next shell is known as second shell. And the next shell is known as third shell. Like that it is numbered. The shells are numbered. The shell closest to the nucleus, we have already studied, the shell closest to the nucleus is associated with less amount of energy. Therefore, that shell carries less number of electrons. The shell more away from the nucleus is associated with the more energy, that means it contains more electrons. Okay, so first shell is named as K shell, second shell is named as L shell, third shell is named as M shell, fourth shell is named as N shell. These are the names for the various shells. So we are going to see how these electrons are arranged in different shells. Okay, so for that, first rule is 2n square rule, where n stands for the number of the shell. So here for the first shell, the n stands 1. So what will be the number of electrons accommodated? Number of electrons that can be accommodated. That can be accommodated in first shell will be equal to 2 into n square, where n stands for the serial number of the shell, means 1. 1 square, that is equal to 2. So the first shell can accommodate maximum 2 electrons. Now what is the second shell? 2 into, second shell means the n stands for the serial number, that means 2. 2 square. So second shell can accommodate maximum 8 electrons. Third shell, 2n square, 2 into 3 square. So that will be equal to 9 into 2, 18. Fourth shell, 2 into 4 square, that is equal to 2 into 16, 32. So like that, the electrons are accommodated in various shells. According to 2n square rule, n stands for the serial number of the shell, and this 2n square will give us the maximum number of electrons that can be accommodated in each shell. Okay, now the second rule states that if an electron has to enter a particular shell, all the inner shells should be filled. Only after filling the inner shells, the next shell starts. That is the second rule. Now third rule, that is more important than the first and second rule. Third rule is known as octet rule. That states that the maximum number of electrons that can be accommodated in the outermost shell is always 8. The maximum number of electrons that can be accommodated in the outermost shell is always 8. It will not be more than 8. So let us see that how it is. So according to 2n square rule, we have seen the first shell can accommodate, first shell or K shell can accommodate 2, second shell can accommodate 8, third shell can accommodate 18 and fourth shell 32. This much we have found out. Now let us see octet rule. Octet rule states the outermost shell of any atom will not be having more than 8 electrons. Should not have more than 8 electrons. Okay, so the hydrogen atom, the atomic number is 1, so electronic configuration is 1 for hydrogen. Helium, there are 2 electrons. Atomic number is 2, so means 2 electrons. So first shell can accommodate 2, so this is the electronic configuration. Lithium 3, so first 2 electron goes to the first shell and the next electron goes to the second shell, because first shell can accommodate only 2. Now 2 plus 1 equal to 3, that is the atomic number, that is the number of electrons present in that atom. Beryllium, atomic number 4, first 2 electron goes to first shell, the remaining 2 electron goes to second shell. Now see oxygen. Oxygen atomic number is 8. So first 2 electron goes to the first shell. There are 8. Atomic number 8 means there are 8 electrons. So first 2 electron goes to the first shell. The remaining goes to the second shell. Second shell can accommodate maximum 8. Now see neon. Neon. First 2 electron goes to the first shell. The next 8 goes to the second shell. Okay, 2, 8. Now sodium. Sodium. Atomic number is 11. So first 2 to the first shell, the next 8 to the second shell. Second shell is filled. The remaining one goes to the third shell. So this is the electronic configuration of sodium. So in the first shell 2, suppose this is sodium, first shell 2, second shell 8. 1, 2, 7, 8. 8 electron and the remaining in the last shell. So this is the electronic configuration, means writing the number of electrons in each shell. That is known as electronic configuration. So this is the electronic configuration of sodium. Now let us see what is electronic configuration of chlorine. Chlorine 17. So electronic configuration will be 2, 8, 7. 2 plus 8, 10 plus 7, 17. Now go argon 18. So argon's electronic configuration will be 2, 8, 8. C8 electrons outermost shell give stability. Now next is potassium 19. 19. So electronic configuration is 2, 8, 9, because third shell can accommodate 18. But according to octet rule, third rule, octet rule states that the outermost shell should not have more than 8. So far when you have written, no atom is having more than 8. But here it has come more than 8. So it is wrong. It is against octet rule. So we will write the electronic configuration as 8, 1. Now it is not against octet rule. But we may have doubt. Ma'am, according to 2n square rule, third shell can accommodate 18 electrons. Why, ma'am? Now you have written like this. That is your doubt, right? But 2n square rule says that the maximum number of electrons that can be accommodated is according to n square. But octet rule says that the maximum number of electrons in the outermost shell should not be more than 8. So which rule is more important? Octet rule. It says should not be more than 8. The other one is saying the maximum electron that can be accommodated is 18. According to 1 square rule, third shell can accommodate 18. It is not compulsory. It can accommodate maximum 18. That's all. So whenever there is a clash between octet rule and 2n square rule, we should follow octet rule. So here there is a clash in this case because according to 2n square rule, third shell can accommodate 9. But according to octet rule, the third shell should, outermost shell should not have more than 8. So we will write it like this. This is the electronic configuration of potassium 90. Next let us see calcium. Calcium, its atomic number is 20. So electronic configuration is 2, 8, 10. This is wrong again. Total number of electrons 20, 2 plus 8 plus 10. It is 20 but outermost shell should not have more than 8 electrons. So again we will rewrite it as H2. Now it is according to the octet rule. Okay. Now the next we need to by heart only up to atomic number 20. According to our syllabus we need to by heart only up to 20. But we are going to the next element for your information. Suppose next element is X, atomic number 21. Okay. So the electronic configuration will be 2, 8, 9, 2. There is no problem in the next electron going into the third shell because now it is not the outermost shell. So this is the electronic configuration of the element with atomic number 21. 22, it will be 2, 8, 10, 2. Like that, the electrons will be filling in the third shell up to 18, 2, 8, 18, 2. Then after that, this is the element with atomic number 30. 2 plus 8, 10 plus 18 plus 2, it is 30. So this is the electronic configuration of element with atomic number 30. Now the next element's electronic configuration will be 2, 8, 18, 3. It goes to the fourth shell. We don't have to study this electronic configuration of elements after atomic number 20, 21, 22, 23, etc. is not needed. But I was just showing you for your information because you may wonder if the third shell is never having more than 8, what is the use of 2n square rule stating that third shell can accommodate 18? They state that third shell can accommodate 18. If we are never giving 18 electron third shell, what is the use of that? You may wonder. That is why I was showing it. Because after 20, atomic number 20, electrons are being filled in the third shell. Okay, up to 18 it is being filled there. Okay, so ma'am has finished electronic configuration in your textbook. Now we will continue in the next class. So study well. You should be able to write electronic configuration of any element up to atom number 20. No use in by hearting the electronic configuration. It is not possible. But just understand the rules. So we will be able to write electronic configuration of any element. Suppose we want to write electronic configuration of an element with suppose 15 phosphorus. So we will write first shell can accommodate maximum 2, second shell can accommodate maximum 8. So 2 plus 8, 10 over. Then again 5 more is there, that is going into third shell. Like that, if we have that awareness about the 2n square rule, octet rule, we will be able to write electronic configuration of any element up to atomic number 20. Among this, only potassium and calcium we should be very careful because third shell should not have more than 8. We should give that fourth electron, next electron to the outermost shell. There should not be 9 in the outermost shell. That we should specially take care. That's all. Thank you.